Hi everybody. In this video, we are going to discuss about how to access the files randomly. That is, move to a particular location directly and access that record. So there are two types of file access. One is sequential, the other one is random. So sequential is moving one after another in a sequential fashion. Say for example, I want to count the number of times a particular word occurs in a given file. So naturally, I'll have to start from the beginning of the file, count the number of times the word occurs till the end. So I'll have to go character by character sequentially. So in this case, you need to use sequential access. So random access is if I want to directly go to a particular position and read or write. Okay, so to do this random access, I can use certain functions. The one is rewind. So rewind will bring the file pointer to the beginning of the file. So rewind can be either used in sequential or random. I'm just bringing the file pointer, returning the file pointer to the beginning. Fseek is to seek to a particular position. Okay, I'm moving the file pointer to a particular position. Ftell, it will return the current position of the file pointer. So I can use ftell to find out where my file pointer is actually positioned now. So fseek has got actually these parameters. Say for example, just take this example. The first parameter is your file pointer. The second one is the position offset. Okay, so that is, just see this, the origin. So seek's origin is from which point I'm going to apply the offset. So seek set is going to be from the beginning. So I am moving the file pointer 0 location or 0 bytes from the beginning of the file. Okay, so my origin can be these things, seek set or 0, both means the starting. Seeker or 1, both means the current position, from the current position. Seek end or 2, both means the end. So here this example says move the file pointer 0 bytes from the starting. That is, keep the file pointer in the starting position. Okay, I can use ftell to find out at which position my file pointer is. So I can say ftell of fp if fp is my file pointer. So it will tell me in which position the file pointer is currently residing. Okay, right. Let us take a very small example. So you can see here, I created a file pointer fp. Okay, so I'm going to use this n to move that many number of bytes backward. Fine. So I'm opening the file in read mode. It's a text file. So my file pointer will be pointing to the beginning of the file. If this file does not exist, or due to some reason, if the file pointer returns null, or if my file pointer is equal to null, then just print file cannot be opened. Otherwise, I'm just reading n, the number of characters. Okay. So I'm moving the file pointer. I'm using here fseek. Fseek moves the file pointer n bytes backward from the end. Okay, I've used here minus n. So n bytes backward from the end of the file. Okay, say for example, I say n is 5. So I'm going to move 5 bytes backwards from the end of the file. So now my file pointer will be positioned in that place. So 5 bytes before the end of the file. So I'm getting the character. If it is not end of file, I'm printing it. Again, get the character, assign it to ch, check whether it is not end of file. If it is not end of file, print. It just continues till my ch becomes end of file. Then I'm closing it. Say for example, this is a sample.txt I'm opening in read mode. If my sample.txt content is this. Okay, this is the content of my sample.txt. In that case, fp of if n is 5. Okay, okay. Here the example is n is 4. So I'm going to move 4 bytes backward from the current position. So from the end, okay? So from the end, I'm going to move 4 bytes backward. So here, my file pointer will be pointing here. So now from there on, I'm reading it. So you can see the output will be 5, okay? So fseek will move the file pointer from the end minus n position. That is from the end, n bytes backward. Is that clear? Okay. Now, you have 2 types of files. One is text file, the other one is binary file. Fine. Now we are going to find out how to write or read from a binary file. So I can use fwrite function to write records to the file. So my fwrite function has got the first one, the PTR, which is a reference of the record. Okay, just remember this. We are going to see the example. So that's the reference of the record. Then the size. Okay, so how many bytes I'm going to write? The total bytes I'm going to write. N is how many times I'm going to write a record. And this one is going to be my file pointer. Is that clear? Okay. So this is fwrite, to write something to the file. fread is to read bytes from the file. So fread, again, the reference of the record. If it's a structure, the structure variable. Okay, the reference of the record. Then the total number of bytes I'm going to read. N is the number of records I'm going to read, or number of times a record. That is number of records I'm going to read. And this is the file pointer. Let me repeat it. Fwrite is to write something to the file. It could be an array or it could be a structure. So PTR is going to be whatever I wanted to write. Okay, the reference of that particular record, a structure or an array. Size is the total number of bytes I want to write. N is the number of records I'm going to write. FP is the file pointer. Similarly for fread is to read bytes from the file. So again, the reference of the array or structure, the reference of the record is PTR. Size is the total number of bytes I'm going to read from the file. N is the number of times the record is going to be read, and file is the file pointer. Okay, so with this in mind, let us try to write a program. Okay, so here I'm going to read, this is my program. I'm going to read this employee details, write to the file. Okay, then I'm just going to print the last employee detail alone. Okay, the first step is I'm going to write, say for example, some n number of employees to the file. Okay, then I'm going to open the file in read mode, use fseek to move to the last record of the file, then read that particular employee alone and write it on the screen. Okay, so for that, you can see here, I created a structure employee, and this is my employee details I'm trying to do. So employee name, grade, and salary. Okay, these are the basic things are kept as it is. Now I'm creating a file pointer, FP, and an employee variable E. Okay, then I open this file in write mode. B is a binary file. Okay, I'm opening sample.txt as a binary file in write mode. Okay, then I'm checking whether FP is null, if the opening has happened properly. If it is equal to null, I'm just printing error, then return. Otherwise, I'll have to read the employee records from the user, then write it to the file. I'll have to continue this till I give the ch. I have a variable called ch, till the ch is going to be 1. Okay, initially my choice is 1. Fine. So now, while ch is equal to 1. So initially my ch is 1. So while ch is equal to 1, let me get, sorry. So printf, I'm going to get first the name, okay, then the grade and the salary. Grade and the salary from the user. Okay, just to display. Fine. Now I'm going to scan the input from the user. So scanf, percentage S is for name, percentage D is for grade, percentage F is for salary. Fine. Now E is my employee variable, right? So E dot name, comma, ampersand E dot grade, comma, ampersand E dot salary. Okay. So I'm getting this record. So I've got the record from the user. Now I need to write this to my file. So I'm going to use fwrite. What I'm going to write? E. So the reference to the structure, ampersand E. Okay, E is a structure variable, right? Then how many bytes I'm going to write? Whatever the size of E I'm going to write. That many number of bytes I'm going to write. How many records I'm going to write? One record. And to which file? F. Okay, so I've written it. Then again, I have to get the input from the user, whether the user wants to continue. Okay, I'm just writing press 1 to continue. Okay, now let me get scanf percentage D ampersand CH. Right? Again, what happens if I give CH is equal to 1, it goes here, the condition becomes true, then gets the name, grade and salary from the user, then writes it to the file. Again, gets whether you want to continue, then writes it to the file. So once I give any number other than 0, it comes out of the while loop. Now let me close this file. That's right. Okay. Now first let us run this program to check whether it's getting returned to the file. Okay. So just a minute. Now let me run this program. So I can see here there is an error. See, there is no bracket here in 26th line. In 26th line, there is no bracket. Yeah. Fine. Now let me run this program. So it's asking name, grade, and salary. Let me write Jayapriya. Grade is 1. Salary, let it be 60,000. Okay. Then it's going to ask. It has to ask actually. Press 1 to continue, right? Okay. Yeah. So let us see what is happening here. There's a mistake here. Okay. So let us see. Let us stop this and see what has happened. So while CH is equal to 1. Okay. So you can see name, grade is integer, salary is float. Okay. So I'm writing all this. Then I'm writing it. Okay. So I've opened the file in write mode. That's great. So once I write it, it has to press 1 to continue. Okay, I don't think there is any error in this. Let us check again. So let me run the program here again. So let me write Subhadra. The grade is 1, salary 60,000. Okay, so now okay, Jayapriya, then 2 grade 25,000. Okay, then let me finish off with 0. Fine. So I have given here 2 records. There is some mistake. Let us check. I don't know what is the mistake. Let us check. So as you can see here, the records has been returned to the file. Okay, a sample.txt is created and it's a binary file. Let us check what is the problem here in this code. So CH is initially 1. It enters So it's, yeah, that's space here. Let us take off the space. Fine. Now let me run this. So Jayapriya, grade is 1, salary. Okay, now, yeah, because just because we gave a space, there was a problem there. Okay, so now press 1 to continue. Then let me give Subha. The grade is going to be 2. The salary is going to be something. Okay, now let me close it. Now, let me give 0 because I don't want to continue. So I've given 2 records now. Okay, so we have given here 2 records. Now let us check the sample.c. You can see here the 2 records has been given to the file. Yes, so this is what has happened now. Okay, now we have returned something to the file. So now what I'm going to do is I've closed the file. So I'm going to open the file in read mode, move the file pointer to the last record, and then print only that last record. So this is what you're going to do right now. Okay, so now let me open the file in read mode. Okay, so my file name is going to be sample.txt. I'm opening the file in read mode because it's a binary file RB. Okay, now I'll let to move to the particular location, the last record. So how do we do it? fseek of, I'm going to move the file pointer to minus size of E from the last position. Right? So what does it do? It moves the file pointer this many bytes backward from the end. Okay, now I'm going to read that particular, now my file pointer will be in the beginning of the last record. So let me read that record, fread of ampersand E, comma, size of E, comma, I'm going to read only one record from the file pointer ft. Okay, then let me print it. Printf. So percentage s is the name. Let me write name equal to. Then backslash n. Then grade equal to percentage d backslash n. Then salary equal to percentage f. Fine. Now comma e dot name e dot grade because I've written it salary e dot salary. So e dot grade. Now e dot salary. Okay. So once I complete it, let me close the file. Let us run this and see how does this work. So run your file. So I'm opening the file again in write mode. Okay. So let me give the input. Jayapriya. Grade is going to be 1, the salary. Okay. Then press 1 to continue. Subha. Grade is going to be 2, then the salary. I'm just giving these values for us to remember. Okay. Then press 1 to continue. Hema. Grade is going to be 3 and the salary. Okay. Okay, so now the problem here is, just a minute. Yeah, so I'll press so just because I've zoomed it, the problem comes in just a minute. So you can see here, I'll press 0. So I've entered 3 records. So once I complete the 3 records, you can see the last record alone is displayed here. Okay, so you can see here. So Jayapriya I've given here, then Subha, okay, then Hema. Okay, So I've given here 3 records. Fine. And then you can see it's just printing the last record of the file. So this is the use of seekg function. So let me explain to you again. So I'm going to write the employee details to the file in a binary file. So I've created a structure. Now I've initialized ch to 1 and the file pointer. And the employee structure variable is e. I've opened this file in write mode, which is a binary file. If the file is not opened properly, fp will be equal to null. So error and then return. Otherwise, it just goes here. We have initialized ch equal to 1. So this condition is true. So it enters here, gets the name, grade, and salary. It just prints, and here it gets the name, grade, and salary from the user, then writes it to the file. So the first employee detail is written. Now it will ask, press 1 to continue. Now for ch, if I give 1, again it goes here, ch is equal to 1. So again, it gets the name, grade, and salary of the second employee from the user, writes it to the file, then again ask whether you want to continue. If you press 1, it goes back and does the same thing again. If you press some number other than 1, it comes out of your while loop and closes. So once this is run, you can see a sample.txt file is created and the employee details has been returned to the file. Now I wanted to go to the last record and print only the last employee detail, just for us to understand fseek. So what I will do, I'm opening the file in read mode. It's a binary file, so RB. Now I'm using this fseek to move my or to position my file pointer. Where? So from the end, I wanted to move the size of the structure backwards. Okay, so I wanted to move. So you can see there's a minus here. That means backwards from the end. Now, how much? This, whatever the size of the employee structure. Okay, that many bytes I wanted to move backward from the end. That's the beginning of the last record. Okay, then that record I'm reading it, storing it in E. Okay, I'm reading that record, store it in E. Then I'm printing all this. So I'll be getting the last employee details on the screen. Finally, let me close the FP. I hope you understand this. Have a great day.